Okay class, today is week number 2, lecture number 10, and today we are going to discuss how we find the inverse of a matrix, right? In our last class we had discussed in detail regarding the multiplication of a matrix, multiplication by a scalar number, and matrix multiplication we had discussed in last class, right? So now in today's class we are going to discuss what is inverse of a matrix and how we are going to find the inverse of a matrix. First thing, how you define the inverse of a matrix. Let's suppose if a matrix A, right, then its inverse will be A power minus 1. That's how the notation of inverse is defined. Similarly, if a matrix is X, then its inverse will be defined by X power negative 1, right? That is a basic notation to define a inverse of a matrix. Now inverse of a matrix has the working formula which says that A inverse is equals to adjoint of A divided by the magnitude of A. Now first thing, in order to find the inverse of a matrix, we need to find out the adjoint and the determinant. Now let's take an example. Let's suppose A is equals to minus 1, 4, minus 2 and 3. Just an example, right? Now what is adjoint? In order to find the adjoint of A, in general, let's say that A is A, B, C, D minus B. So adjoint will be, you need to swap the position of A and D, right? You need to swap the position. So instead of A, I'm going to write D, and instead of D, I'm going to write A. And second thing, you need to change the sign of B and C. So if it's negative B, then it will be positive B, and if it's positive C, then it will be negative C. So that's how you find the adjoint, right? So in adjoint we have completed two steps. One, swap position of A and D. Number two, swap sign, not swap, in fact change sign, change sign of B and C, right? These are the two steps to find the adjoint. Now if we are going to apply the same adjoint principle in our question, then adjoint of A of our example, it will be, first we need to swap the position of A and D, right? This one is A and this one is D as compared to this matrix. So if you swap the position, it will be 3 and negative 1, right? The placement of A and D has been swapped. Now the signs of B and C, if it is positive 4, then we are going to write it negative 4, and if it's negative 2, then it will be positive 2. So that is first step completed regarding the inverse of a matrix. Now the next step, comparative to easy as adjoint, the determinant. So you can say determinant or you can say magnitude, both are same words. Determinant represented by the two bars outside the A. Now the working formula to find the determinant, it is AD minus BC, AD minus BC, right? Now we know the positions of A, B, C and D from our matrix, so we need to place the working formula in our example. Now A modulus, it will be AD minus BC, right? So the position of A in our case is negative 1, so A is negative 1. The position of D is 3, so D is 3, minus from the formula, right? AD minus B and C. So B is what? 4 and C is negative 2. That is the working formula of modulus. Minus 1 times 3 is minus 3, minus minus plus, 4 times 2 is 8, that means modulus of A is 5, right? So now we have adjoint and we have modulus. We need to substitute these two in this inverse working formula. So it will be A inverse is equals to, the adjoint was 3, 2, -4, -1 divided by the magnitude is 5, or you can write it in this form, 1 upon 5 with the matrix 3, 2, -4, -1, and that is your answer of matrix inverse, right? That is your A inverse. So that is a method to find the inverse of any matrix. Keep in mind, in order to find the inverse of a matrix, you need to find out two things. One is adjoint of A and the other one is magnitude of A. For adjoint of A, you need to swap the positions of A and D and change the sign of B and C, right? That's how we find the adjoint. For determinant of A, you need to cross multiply AD and BC and then you need to subtract it. When you got these two values, you need to place it in a working formula. So that's how you find the inverse of a matrix. After inverse of a matrix, there is one unique matrix and we call it singular matrix. Now what is singular matrix? Write it down. A matrix with zero determinant. A matrix whose determinant is 0 is called singular matrix, right? And the next property of singular matrix, inverse is not possible. Why inverse is not possible? We had studied earlier that A inverse is equals to adjoint of A divided by magnitude of A, right? If A magnitude is 0 in case of singular matrix, then in the denominator we have 0, right? And when we have denominator in 0, so this expression is unsolvable, that is equals to infinity. So that's why when we have a singular matrix, that means its inverse is not possible. Now in your CIs, examiner never asks that what is singular matrix or define singular matrix. It never asks for the definition, but the question comes in such a way that it is mentioned that A is equals to A to B 5, find B if A is singular matrix. Now that's how examiner asks a question in papers. It never asks you to write the definition, but it checks you to whether you have a clear idea or the concept is clear or not. So now it says singular matrix. We know that a matrix whose determinant is 0 is called singular matrix, right? So first thing, you need to apply the condition determinant is equals to 0. After that, you need to substitute the working formula which says A D minus B C is equals to 0. I wrote the working formula of determinant, right? So to make it more easy, I am going to write the variables above the numbers. So A is 8, D is 5, B is 2 and C is B. So it will be 40 minus 2C is equals to 0. If you further solve it, it will be 40 is equals to 2C and C is equals to 40 divided by 2, that is 20. So when you have a concept of singular matrix, then you can solve such type of question, right? And you can see in past papers that such questions comes oftenly. So moving on to our book exercise, it's exercise 5D, same book 4. Exercise 5D. Going to start with question number 1. It says that you need to find out the determinant in part A. You need to find out the determinant, and in part B you need to find inverse of a matrix, whether it is possible or not, right? So I'm going to start with part 1. Part 1 says 3, 5, 4, 6, right? Now you need to find the determinant first. So determinant, we know that working formula is AD minus BC. So A is 3, D is 6, B is 4 and C is 5, right? So 3 times 6, 18 minus 5 fours are 20. So determinant is negative 2. That is your answer of first part. Now determinant is not 0, that means inverse is possible. So now we need to find the inverse. For inverse, first step you need to find the adjoint. So adjoint of that matrix given above, you need to swap the placement of A and D. So it will be 6, it is 3. You need to change the sign of B and C. So it will be negative 4 and it will be negative 5. So that is an answer of adjoint of a matrix. Now the final answer of A inverse or inverse of a matrix. You know that for inverse, first you need to write adjoint and then determinant, right? So adjoint value is 6, negative 5, negative 4, 3 divided by determinant is what? Negative 2, right? Now you can write it in two forms. One is minus 1 upon 2, the determinant, and then your matrix 6, minus 5, minus 4, 3. That is also acceptable. Or if you solve it further, you multiply all the elements by negative 1 upon 2. So it will be minus 3, it will be 2, it will be 5 upon 2, and it will be negative 3 divided by 2. So both answers are correct. How can I get this one? I multiplied all the elements with minus 1 upon 2. So 6 into 1 upon 2, it will be 3. Minus 4 into minus 1 upon 2, it will be positive 2. Minus 5 into minus 1 upon 2, 5 upon 2. And 3 into minus 1 upon 2 will be minus 3 upon 2. So that's how you solve a question of inverse. So that I have done part 1. After part 1, moving on to part 3. It says 3152. The same concept, same method. 3152. First step, you need to find out the determinant. Determinant is what? A, D minus B, C. A is what? 3, D is 2, B is 5 and 1. So it will be 6 minus 5 implies that 1. So we got the, let's suppose this matrix is B, right? So we got the determinant of B is 1. Now we need to find the adjoint of B. So for adjoint of B, first we need to swap the position of A and D. So instead of A, we are going to write D, that is 2. Instead of D, it will be 3. You need to change the sign of B and C. So minus 5 and minus 1. That is your adjoint of B. Now final step, to find the inverse of a B, it will be adjoint. So adjoint is 2 minus 1 minus 5, 3 divided by determinant is 1. So your final answer, it will be 2 minus 1 minus 5, 3. That is your final answer, right? So far so good. I hope that this method is clear to you. Moving on to next question. After part 3, it's part 5. It says -8, -4, -4, -2, right? So at this step, I need you to stop the video and solve this question by yourself and then see if your answer is right or wrong. So let's say at first I'm going to label the matrix and let's say it is C. When I'm going to find magnitude of C, determinant of C, it will be A, D minus B, C. So A is -8, D is -2, B -4 and C -4. So -8 -2 it will be +16, minus -4 -4 it is 16. 16 minus 16 is 0. So determinant of C is 0, and since it is a singular matrix, so inverse of C is not possible, because now you can write C is singular matrix, or you can write magnitude of C is equals to 0. They both are correct, both meanings are same, right? Because C is a singular matrix, and how we know that it is a singular matrix? Because its determinant is 0, and those matrices whose determinants are 0, they are singular and their inverse is not possible, right? So after question number 5, I'm going towards question number part 7. It says 1 0 0 1. In our last class, I have told you that this matrix is an identity matrix, and we had discussed the property of identity matrix as well. So first thing you need to find, let's label this matrix D. So D determinant 1 into 1 is 1, minus 0 times 0 is 0, so 1 minus 0 1. Now you need to find the determinant. So determinant of D, it will be same, 1 0 0 1, right? So if you find out the determinant, 1 0 0 1 divided by 1 is equals to 1 0 0 1. So inverse of I matrix is basically equal to I itself, right? So after part 7, what you guys need to do, I'm giving you a homework. It's exercise 5T, question number 1, and we had covered all the odd number parts. You guys need to do all the even numbers, 2 4 6 and 8. These 4 parts you need to do from the exercise 5D, question number 1, the same method that I discussed with you right now. Now after question number 1, moving towards question number 2. If A is equals to 2 3 5 8 and B is equals to 8 minus 5 minus 3 2, find AB and BA. Okay, so you need to find AB and you need to find BA, and then determine the relationship between A and B. Okay, so at first you may like to stop the video and try it by yourself, it will be good. So first thing, we need to find A into B. So matrix A is 2 5 3 8 multiply by 8 minus 5 minus 3 2. Like I have told you that always first step is to check the condition. So the both matrix have same order of 2 by 2, right? Condition is valid, so we can multiply, and before multiplication you need to draw the arrows. So first one always has a horizontal arrow and the next one is always has a vertical arrows. Now starting our multiplication, 2 is on the tail side, so tail multiplies with tail. When we moving towards 3, use positive sign. 3 multiplies with negative 5, right? Now the same row matrix, 2 multiplies with negative 3 plus 3 multiplies with 2, right? We are going to do the same for the second row. So 5 times 8 plus 8 times negative 5, 5 times minus 3 plus 8 times 2, right? Further simplification, 2 times 8 is 16 plus minus 3 times 5 is 15. 5 8s are 40 minus 8 5s are 40. 2 minus 3 minus 6 plus 6 and minus 15 plus 16, right? And if you further solve it, it will be 1 0 0 1. That is an identity matrix. So AB is basically an identity matrix, right? Now we need to solve for BA as well. Starting with the same strategy, BA. At first we need to write the matrix B. 8 minus 5 minus 3 2 multiply by A. 2 5 3 8. Now in last part I had covered the matrix multiplication, right? So you need to try it by yourself first and then I will see what is the answer. So first thing you need to check the condition. As we can see that both matrices order is same, so condition is valid. After that you need to plot the arrow first. First one row wise, second one column wise, right? And then start the matrix multiplication. So it's 8 times 2 negative 3 times 5. 8 times 3 minus 3 times 8. Negative 5 times 2 plus 2 times 5 and negative 5 times 3 plus 2 times 8. In order to check your solution, make sure that these numbers should be same, right? After that, further simplify it. 8 times 2 is 16 minus 15 minus 10 plus 10. 24 minus 24 minus 15 plus 16. So 16 minus 15 is 1 0 0 1, right? So that is BA. Now AB or BA, they both are equal. They both are equal matrix and they both equals to identity matrix. And we had discussed in our last class that identity matrix is such a matrix whose elements are 1 0 0 1, right? And the next important property of an identity matrix, which I have told you in last lecture that we will cover in matrix inverse lecture, when a matrix multiplies with its inverse, it's always result in identity matrix, right? Keep in mind, when a matrix multiplies with its inverse, it always results in identity matrix. Now in your question it says that describe the relationship between A and B. Now in our answer, if you say that A times B is equals to 1 0 0 1, just write here, right? And A multiplied by B is equals to 1 0 0 1, basically identity matrix. Now compare this expression with this equation, right? or if I write below it, so it is A times B is equals to I. Now you can create a relationship between A and B. Basically A and B both are inverse matrix of one another, and that is the relation the examiner is asking you in the question. Both matrices are inverse of one another, and how we know that? According to the condition, we know that when a matrix multiplies by its inverse, it is an identity matrix. That is a property of I matrix. So if A multiplies with B and results in identity matrix, that means that B is basically A inverse. Similarly, in your next part, it says B times A is equals to I matrix. So basically it is written that B times B inverse equal to I matrix, and I basically equal to inverse of B, right? So that is the relationship between A and B, that both matrices are inverse of one another, right? So moving on to the same type of questions for your practice. Now let's say I have a matrix X, it's 5 3 0 1. You need to find out X inverse, right? So first step, you need to find the determinant of X. So X determinant is equals to A D minus B C. So A is 5, D is 1, B is 3, and C is 0. So X determinant is equals to 5, right? After the determinant of X, you need to find the adjoint. Adjoint of X, it will be swap the position of A and D. So it will be 1 and it will be 5. Now change the sign of B and C. So the final step for X inverse, it will be adjoint divided by determinant. Adjoint, we had find out 1 0 negative 3 5 divided by magnitude is 5. So we can write that 1 over 5 times 1 0 minus 3 5, that is answer of the matrix of X inverse. Moving on to the next question, it's question number 3 from your book. It says that if P is 7 9 3 4 and Q is 4 negative 3 negative 9 and 7, find QP and PQ. PQ and QP. We have done a similar question number 2 like this one. So first thing you need to do is write by yourself, right? So on the left side, I'm going to find PQ. So P is 7 3 9 4 times Q, 4 negative 3 negative 9 7. Now you guys, if you are making mistake in multiplication, then try to make that arrow, right? Now start multiplication with the same head to tail method. 7 is on the tail side, it multiplies with 4 plus 9 multiplies with negative 3. After that, 7 times negative 3 plus 9 times 7, right? Second row, 3 times 4 plus 4 times minus 3 and 3 times minus 9 plus 4 times 7. Further solve it. So 7 4s are 28, 3 9s are 27. It will be 12 minus 12. 7 times minus 3 is minus 63 plus 63 minus 27 plus 28, right? Further simplification, 28 minus 27, 1, 0, 0, 1. So basically PQ is equals to I matrix, or you can say that Q is equals to inverse of P in this condition, right? As we had discussed in question number part 2. After PQ, we are going to find QP. So matrix Q, 4 minus 3 minus 9, 7 times P, 7, 3, 9, 4, right? Solve it further with the same arrow method. So tail with the tail, that means 4 times 7, 28, minus 9 times 3, 27, right? Minus 3 times 7 is 21. So I am going to write directly 21. After that plus. Now 7 times 3, head with the head, right? So 7 times 3 is 21, right? Now I am going to multiply. 4 on the tail side will be multiplied with the tail side. So 4 multiplies with 9, 4 9s are 36, right? And then negative 9 multiplies with 4, head with the head. So negative 9 multiplied with the 4, it will be negative 36, right? Similarly, negative 3 multiplies with 9, it will be negative 27, plus 7 4s are 28. Further simplification, 28 minus 27, 1, 21 21 cancel out, 36 36 cancel out, 27 28, 1. So like question number 2, part 2, QP is 1 0 0 1. Now the relationship between P and Q, P and Q are inverse of one another. That is the relationship between P and Q, right? So I hope that in today's class you have an idea how we solve multiplication question, right, and how we solve inverse of a matrix, right? We had discussed from the very basics of the inverse till the questions. So keep in mind that whenever you need to find the matrix inverse, you need to find its determinant and then you need to find its adjoint. And adjoint of a matrix, as I have told you, that you need to change the positions, right? You need to change the positions of A and D, and you need to change the sign of B and C. Once you find the adjoint and determinant, you need to place in the matrix inverse working formula, right? And after the substitution, you need to simplify it. So you can leave your answer till here, or you can divide 1 upon 5 through all the members. It's up to you. So it's enough for today's class, right? And I had given you homework, 4 parts you need to do at your home. I hope that all of you have a clear idea how to solve matrix multiplication questions. In next class we continue this topic and we are going to solve some past papers question, right? Till then, take care and Allah Hafiz.